Okay, we're going to jump right into 3.2, using parallel lines and transversals. Yesterday, we talked about basically identifying the corresponding, the alternate interior, alternate exterior, the same side interior, same side exterior. We learned about all these different angle types. Obviously, 3.1 kind of introduces you to the main vocabulary. Now we're going to go ahead and actually apply these in order to help us figure out some angle measures and solves and stuff like that. So again, what you're looking at right now is you're looking at two parallel lines and a transversal. Okay, and if you see this here, this shows you that you have two parallel lines, and then this is the transversal. It's almost vertical, or whatever the case is. Now, let's go ahead and name these angles. So here you have angle 1, 2, 3, and 4. And here you have 5, 6, 7, and 8. Okay? First thing I want to do is I want to talk about what these are. As of yesterday, you should have learned that angle 1 and 2, angle 1 and 5 are corresponding angles. They're in the same spot on the same side of the transversal. This one's above the parallel line here. This one's above the parallel line here. They're both on the left side of the transversal. Okay? 4 and 8 are corresponding. They're both on the same side of the transversal, and they're both on the bottom of the line. Okay? 2 and 6 are both corresponding angles because they're both on the same side of the transversal. And one is on top. They're both on the top. And 3 and 7 are corresponding as well because they are both on the bottom on the same side of the transversal. Okay? Alternate interior angles. Remember what we talked about yesterday. Interior are the angles that are inside, so 3, 4, 5, 6, the ones that are inside the parallel lines. Okay? Alternating, one on one side of the transversal, one on the other side of the transversal. So your alternating interior angles are 3 and 5 and 4 and 6. Alternating exteriors, again, the exteriors are the ones on the outside of the parallel lines. Okay? You have 1, 2, 8, and 7 that are the alternating exterior angles. In fact, I need to... No, we're good. Yeah. Okay? So 1 and 7, this is on the left. 1 is on the left side. The alternate would be the right side. Okay? So 7's on the other side. So that's your alternate exterior angles. Again, look at this like footprint, like a footstep. Left or right, left. There's your footsteps. Here is another footstep. Left, right. And now you have 2 and 8 being alternate exterior angles. Okay, those are the three primary ones that we're going to look at right now. Some of the ones you might already know are 2 and 4 are vertical. Same thing as 1 and 3, 5 and 7, and 8 and 6. And also you can notice that 1 and 2 are what kind of angles? They're supplementary angles. Okay, 1 and 2 are supplementary angles. 3 and 4 are supplementary angles. 5 and 6 are supplementary angles. And 8 and 7 are supplementary angles. All of that will factor in as we continue through this chapter. Okay. Real quick before I go any further, I want to tell you guys are doing a great job working on chapter 3. I think I see a lot of good work going on in class. I know I see a lot of good work going on in class. The bell ringers so far to this point have been good. Keep up the great work. Okay. All right. So what we're going to do now is, now that we've learned and we just reviewed all the angle measures the names of the angles that we've talked about, angle pairs. One thing you have to remember is this, is that a pair means one of these 4 angles paired up with one of these 4 angles. You're not going to have an angle pair that's 1 and 2 or 2 and 4. Those are vertical angles, but when we're talking about these alternate exterior, interior, corresponding, and so on, you're taking one from this group and one from this group. Okay? Now, what we're going to do is this. We're going to actually apply those now. And once we apply them, it'll help us solve these angles. Okay? So I'm going to move these over because I want to show you some angle measures. Once I get one angle measure, I should be able to get all of them. And you'll see why in just a second. All right. If the measure of angle 1 is 94 degrees, 94.6 degrees, what can you tell me about the measure of angle 3? Okay, you should be able to tell me it's 94.6 degrees because of vertical angles. Now, set that aside for just a second, okay? Because now I want to talk about your alternate interior, exterior, and corresponding and how they relate, okay? If I take this parallel line and I move it down, notice how it fits nicely on top of the other line. If I do that, can you tell me what this angle right here is? Yeah, it should be the same angle as this angle right here, right? So if that being said, what can you tell me about 1 and 5? They are corresponding angles, first of all. And corresponding angles, if you said this is 94.6, when I move that line down, it kept the same angle, so measure of angle 5 should be 94.6. So these two angles are corresponding, and they're both 94.6. Let's look at angle 4. Angle 4 is 85.4 degrees. It's got a corresponding angle of angle 8. What do you think angle 8's degree measure is? 85.4. Just like angle 4. Let's look at angle 2. Angle 2 is 85.4 degrees. What do you think 6 is? 85.4. Angle 3, we already said is 94.6 because of the vertical angle. So we can throw 94.6 up there. But what do you think angle 7 is? Yeah, 94.6 as well. And that was all based on corresponding angles. Okay? So what conjecture can you make about corresponding angles? You can conject that corresponding angles are congruent. So in this case here, we have angles 2 is congruent to angle 6. We can see that. Here's 6 and 2. Angle 3 and angle 7 are congruent. Angle 1 and angle 5 are congruent. And angle 4 and angle 8 are congruent. So you might make a note in your notes, on your notes, that corresponding angles are congruent. It's one of the theorems that you're going to learn, okay? Or that you should commit to memory. But like I said, we're not really going into two-column proofs as much as we did in the last chapter, so it's kind of a logic deal. But there is a theorem that proves that, okay? Now let's take a look at these other angles. Let's look at alternate exterior angles. Okay, what are our alternate exterior angles again? Well, here's, remember, exterior, so outside of the parallel lines. So that's 1, 2, 8, and 7. What's the alternating exterior? Alternating here, if I have 1, the alternate one is, it's on the left side of the transversal, so go to the right side. The right side is 94.6, it's 7. The left side is 94.6, it's 1. So angles 1 and 7 are alternate exterior angles, and they are congruent. Angles 2 and 8, 8's on the left, 2's on the right. They're alternate exterior angles, and they're congruent. So what conjecture can you make about alternate exterior angles? They are congruent. What about alternate interior angles? That's all these angles right here, 3, 4, 5, 6. Well, 4 is on the left. It alternates with 6 on the right. Notice that they're both 85.6. 3 is on the right. 5 is on the left. They're both 94.6. So the conjecture you can make there too is that they are congruent. Alternate interior angles are congruent. Whoops. Okay, pretty simple. Okay, now let's look at the same drawing or the same figure, and let's talk about our consecutive interior angles. So our consecutive interior, again, interior inside the parallel lines, 3, 4, 5, 6. These are consecutive, one right after the other. The consecutive interior angles are what? What can you tell me about the consecutive interior angles? That's right, if I add them together, I end up with 180 degrees. 85.4 and 94.6 is 180 degrees. Over here, consecutive interior angles, angle 3 plus angle 6, 94.6 plus 85.4, also equals 180 degrees. Okay? What about same side exterior angles? That's kind of like our consecutive interior angles, but they're not consecutive. So same side exterior, which didn't talk a whole lot about that in class today, but that's angle 1 and angle 8 are same side exterior, outside, same side of the transversal, excuse me, same side of the transversal, outside of the two parallel lines. If you look at those, you have angle 1 plus angle 8 is equal to 180 degrees too. 94.6 plus 85.4. Another same side pairing is 2 and 7. You add 85.4 plus 94.6, and you end up with 180 degrees. So same side exterior angles, the conjecture you can make there, are equal to 180 degrees. So these three alternate, all of the other ones are are congruent, including vertical angles. The only two that are supplementary or add or create linear pairs are consecutive interior and same side exterior. Okay, make sure you have all this in your notes. Let's take a look at this example. Okay? Oops, I'm showing stuff everywhere. Here we have two sets of parallel lines, and so essentially what we have here are two parallel lines and a transversal, or two parallel lines and another transversal, or two parallel lines and this transversal. So when we start this, the first thing we want to do is if we're given this angle here, let's go ahead and put another arc up there to see what lines go together. These arcs indicate congruency. Okay? Well, if we're dealing with these two parallel lines and this being the transversal right here, then these are congruent because we know vertical angles. And these are congruent because of vertical angles. But why are these congruent to one another? Why is this one congruent to this one? Corresponding angles, that's right. What about why is this one congruent to this one? How about alternate exterior angles? That's right. Why is this one congruent to this one? Whoops, this one. Alternate interior angles, that's right. Okay. So with that being said, let's go ahead and figure out what are we given here? Are we given one of the angles that's congruent? No, we're given 78 degrees. Okay, that's not congruent because there's no arc there. But can I figure out what this is? How do I figure out what this is? Well, that's right. These are a linear pair, so take 180 minus 78 and you get 102. Or you can look at this x degrees if I'm told to solve for x, and I can figure out that 78 plus x, because these are same side exterior, I'm sorry, in this case they're interior, so corresponding interiors, we know that they add up to 180. So you could do 78 plus x equals 180 and you get 102. So a lot of different ways to solve for that unknown variable. What about down here? What if I'm given 110 there? Notice the same congruency as the other ones. So this is 110, this is 110, this is 110. What if I'm given y here? What do you know about these? That's right, they're also congruent. So that's 110. What if I'm given these two angles? 2x plus 24 equals 4x minus 38. How would I solve for x? That's right, I'd set them equal to each other because they're congruent. Definition of congruency. What if I have these two angles? How do I solve for x here? Are they congruent? No, this one's got a green arc, this doesn't. They're not congruent. So that means I know that they're probably supplementary, because if they're not congruent, they must be supplementary, because that's how the other ones work out for the most part. Okay? And so what I would do then is 4x plus 3x plus 30 equals 180. All right, so that's just brief notes on the homework assignment. I went fast and furious because I wanted to get it all in and try to keep it short for you. So good luck.